Welcome. In this video we're going to work through two examples for solving for x. Both of these examples in this video I think focus on using the distributive property, which is something I think is always important to review because this property is something that can lead you to correctly solve more complicated algebra problems, especially when solving for x. So what does this property say? Well, what the distributive property says is that if you have a number, let's say a, and you're multiplying it by something like two other terms, b plus or minus c, right? So you're multiplying a by the sum plus or the difference of two terms. That's the same thing as multiplying by a times b and then adding or subtracting, depending on what you have, a times c. It's a basic idea that we use all the time. If you were going to do 15, right, times 10, well, you could think of this as 15 times, right, 5 plus 15 times 5. So here, what are we doing? Well, 5 and 5 is 10, right? So this is really saying 15 times 5 plus 5. That's how we're changing this right here. And that's this form right here. This can be thought of as 15 or A, and then B, and then C. And we know that 15 times 5 and 5 means 15 times 10. And what do we get? Well, we could do 15 times 5 first. That's what this is saying right here. And then 15 times another 5 to figure this out, right? And 15 times 5 is just 75. So this gives you 75 and 75. 15 times 5 plus 15 times 5, which is the same as just thinking about 15 times 10, right? It gives you 150, or the answer. That's the basic idea of the distributive property, and here it becomes very useful, right, to solve for x. Because what happens is, you can see it says, maybe you can't, I'll rewrite it, 5 times 2x, right, minus 4 equals 10. Well, this is saying 5 is being multiplied by both 2x and then 4, and the difference of them because we're subtracting. So in order to really start to solve for x, we can't really add 4 or touch these numbers yet until we distribute the 5, until we multiply. And what we get is, well, 5 times 2x is what? Well, it's 5 groups of 2x's, or that's 10x's, minus 5 times 4. Which is, well, 20. And now we have this equation, and to solve here, right, we have 10x minus 20 equals 10. I want to isolate x, so I'm going to undo the subtraction of 20 by adding 20 to both sides. What that does is it makes the problem easier to read. Negative 20 and positive 20 is 0, 10 and 20 is 30, and now it's very easy to see that, well, x has to be 3, right, because 10x equals 30. And if we can't see it there, since 10x means 10 times x, we can undo that multiplication by dividing both sides by 10, right? 10x divided by 10, what's that? Well, 10 divided by 10 is 1. So x equals 30 divided by 10, which is, well, that's 3. And that's our answer. So the distributive property allows us to deal with this problem, and it'll allow us to quickly solve it. If we didn't have that property, it might be a little tougher to deal with this problem. Another way of solving it, though, if you want an alternate way, sometimes this works nicely. If you have 5 times 2x minus 4 equals 10, well, since this means the product of 5 and this term, 2x minus 4, we could divide both sides by 5. We can undo the multiplication by division. And that works nicely here because 10 is a multiple of 5. If 10 wasn't a multiple of 5, we'd get a decimal or fraction. And that might be unavoidable in the problem, but if we can avoid decimals and fractions, it might make our life easier. But since 10 is a multiple of 5, what happens here? Well, 5 times something divided by 5 is 1, right? 5 times something divided by 5 is not 1, it's that something. It's 5 divided by 5, it's 1. Right? If you take 5, multiply it by a number like 3, and then you divide it by 5, well, then you just get 3. So 5 times a number divided by 5 is just that number. We don't have a number here, we have a term, but either way, these two 5s cancel out. And then 10 divided by 5 is just 2. So now we have 2x minus 4 equals 2. We add 4 to both sides and get what? Well, minus 4 plus 4 is 0. 2 plus 4 is 6. And 2x equals 6. Divide both sides by 2. And x equals 3. Because 2 divided by 2 is 1 and 6 divided by 2 is 3. So either way we get the same answer. But when you see a problem like this, you should think, okay, is this number on this side here a multiple of this number? If so, you can divide both sides by this number. That might save you some time. Let's look at the second example. It says 15x minus 3 times 3x plus 4 equals 6. So the first thing I'm going to do here is distribute the 3 to every part in here. So I'm going to write 15x minus, and now, well, I guess what's easier to work with here is if we rewrite this beginning equation. Instead of subtracting 3, I'm going to rewrite it as adding, right, a negative 3. And that allows me to keep, let me fix that, that allows me to keep track of the negative signs. And it's just, I mean, we don't have to do this. We can leave it as a minus a plus and then distribute a positive 3. If we do it right, we'll get the same answer. But I find this easier to work with now because we're directly applying the negative 3 to both numbers. So here we go. We add negative 3 times 3x, and that's negative 9x. And then what we have is negative 3 times negative 4, which is just negative 12. So we're adding negative 12, and that equals 6. And again, that's just my personal preference. I think it's easier to work with distributing a negative number, and that instead of subtracting the product of numbers. So anyway, I'll show both ways in a moment. So here 15x, this means plus a minus, that's just 15x minus 9x, right? Adding a negative is the same thing as subtracting a positive, minus 12. And I know this seems a little tricky, and why am I doing this? Well, again, it just helps you keep track of the negative sign. So 15x minus 9x, that's 6x. Minus 12 equals 6. I want to add 12 to both sides. And we get, well, minus 12 plus 12, that's 0. 6 and 12 is 18. 6x equals 18. I'll rewrite it up here, 6x equals 18. That means 6 times something is 18. So to find out what to multiply by 6 to get 18, I divide both sides by 6. 6 divided by 6 cancels out. 18 divided by 6 is 3, and x is 3, just like it was in the last video. Now let's talk about two other options for solving this problem, because I think having a variety of strategies is helpful. So let me go back and resolve. So it's 15 minus 3 times 3x plus 4 equals 6. Well, let's keep the negative sign here and see what happens. So we have 15x minus, and we want to keep track of this carefully, 3 times 3x is 9x, and 3 times 4 is 12, equals 6. And now this is just that tricky part, because often I think if I do it this way, where I distribute a positive 3, I just have to remember now that I'm subtracting everything here. So it's 15x minus 9x, and then minus 12, right? We're subtracting both parts here. And if we can't see that, we can redistribute this as minus 1 times these two parts, and that reverses the signs, and that equals 6. Of course, we'll get the same answer now, because 15x minus 9x is 6x. This is still 12, add 12 to both sides, and 6x equals 18. Divide both sides by 6, and x equals 3. So the difference in this strategy is this beginning approach right here. And that's just a matter of the way you solve it. So it's up to you. And let's try one more way. Another way to deal with a problem like this, when you have multiplication, you can distribute the number or try and divide everything by that number, every term, So here the number is what? Well, I'm going to think of it as 3. And I divide everything by 3 right across. And this is nice because 6 divided by 3 is 2. This term divided by 3 will just be 3x plus 4, right? And 15x divided by 3 is 5x. Well, here we're subtracting still, don't want to forget that sign. And now we'll get the same answer, right? So basically I just divide everything by 3 to simplify. 5x minus 3x is 2x. And then we were minusing 4, so minus 4 equals 2. And you can probably see it already. This is the same thing as before. 2x minus 4 is 2. Add 4 to both sides, and we get, well, 2x equals 6. So then x equals 3. So, there are a variety of ways to approach these problems. I hope one of these is something you think you might want to use. And if not, just realize that certain problems will really be much more friendly with certain strategies than others. So you want to have a variety of ways to solve these. All right, thanks.